Welcome to The Explainer. Today, we're exploring a concept that quite literally rewrites the rules of reality. We're talking about the architecture of the atom, and specifically Ernest Rutherford's groundbreaking nuclear model. It is completely mind-bending stuff, so let's just get right into it.
Section 1. The illusion of solid matter. Okay, let's dive into this and actually challenge our everyday perception of the seemingly solid world around us. We think of the world as undeniably solid, right? The desk you might be sitting at, the floor beneath your feet. Our everyday experience tells us that matter is dense, heavy, and continuous. But to really grasp the true nature of the atom, we have to completely look past that feeling. I want you to visualize a massive sports stadium. Picture the towering grandstands, the sprawling field, just the sheer cavernous volume of that space. Now imagine walking right into the exact center of that field and placing down a single tiny marble. In Rutherford's model, that tiny marble, that represents the nucleus of the atom. And that massive echoing empty stadium space, well, that represents the rest of the atom. It absolutely blows my mind every time I think about it. It brilliantly illustrates just how incredibly tiny the core of an atom is compared to its overall boundaries. So the crucial point is, most of the atom is entirely empty space. Just let that sink in for a second. The solid objects around us, the screens we're looking at, even our own bodies, they're overwhelmingly composed of absolute nothingness. Before Rutherford, scientists assumed the mass of an atom was just kind of spread out evenly. But this realization, it totally shifted the paradigm of science. It means that physical reality is far more porous, almost ghost-like really, than anyone previously dared to imagine. Section 2. The Gold Foil Investigation. Let's transition into the actual detective story of exactly how Ernest Rutherford discovered this hidden reality. To figure out that solid objects are essentially empty space, Rutherford had to set up what was basically a microscopic crime scene. You see, he needed a way to map out the internal structure of an atom without ever actually seeing it. So he built a microscopic shooting range. Step 1. He fired a beam of positively charged alpha particles directly at an incredibly thin sheet of gold foil. Step 2, he placed a detecting screen all around the foil to observe how those particles scattered after they hit the gold atoms. It's kind of like throwing a handful of small stones at an invisible object in the dark. By tracking exactly where the stones end up, you can logically deduce the shape of whatever they just bounced off of. Section 3, decoding the clues. Now we have to decipher these incoming particle scatter data as if they were invisible clues. Now, what's really interesting about this slide is how we can map these specific scattering patterns directly to their shockingly profound meanings. As the alpha particles hit the detecting screen, they created tiny flashes of light. When Rutherford and his team tracked these flashes, the data was, frankly, completely shocking. First, most particles passed straight through the gold foil as if absolutely nothing was there, proving definitively that most of the atom is empty space. Second, some particles deflected slightly off their path. Now, since alpha particles carry a positive charge, this slight deflection meant a concentrated positive charge existed somewhere inside pushing them away. But here is the wildest part. A very, very few particles hit the gold foil and actually bounced straight back toward the source. For a fast-moving particle to bounce backward, it had to have collided with something incredibly massive and compact. No way around it. The atom had to contain a very small, remarkably dense nucleus.
Piecing all these invisible clues together, Rutherford formulated a revolutionary new model. He proposed that an atom features a tiny, dense, positively charged nucleus right at its center, while negatively charged electrons revolve around it, much like planets orbiting the sun. This model perfectly accounted for the experiment's observations. The empty space explains why most particles pass through, the positive nucleus explains those slight deflections, and the extreme density of that tiny nucleus explains those rare shocking moments when a particle bounced right back at them.
Let's quickly consolidate the reveal of this newly discovered architecture. First, the nucleus contains the positive charge. Second, electrons are constantly moving around it. Third, the atom is mostly empty space. And fourth, and this is incredibly important, almost all of the atom's mass is concentrated inside that impossibly tiny central nucleus. The orbiting electrons, they have practically no mass at all in comparison. Literally all the weight and substance of the matter around you is concentrated in those microscopic, super dense centers. Section 4, Impacts and the Lingering Mystery. This is why this matters. It introduced the concept of the atomic nucleus and completely, fundamentally revolutionized our understanding of nature. Rutherford's work undeniably gave us the foundation for modern physics. It paved the way for things like nuclear energy and medical imaging. But despite its absolute brilliance, his model eventually hit a brick wall with classical physics. First, it couldn't explain atomic spectra, the specific frequencies of light that different atoms emit. But more severely, and this brilliantly illustrates a major flaw in the model, it could not explain why orbiting electrons do not lose energy and fall into the nucleus. A charged particle moving in a circle should constantly emit radiation and lose energy, and if it loses energy, its orbit should inevitably decay. Which leaves us with a truly profound question. If orbiting electrons are supposed to lose energy according to the established laws of physics, why don't they fall into the nucleus and collapse the atom entirely? Think about it for a second. If Rutherford's model was 100% correct based on classical physics, every single atom in the universe should spiral inward and destroy itself in a fraction of a second. You, me, the Earth, none of it should exist. The very fact that matter is stable meant there was a crucial piece of the puzzle still missing. It's a massive cliffhanger, a mystery that would eventually require an entirely new branch of science to solve. But we'll have to save the bizarre rules of quantum mechanics for another explainer. Thanks for joining me today, and keep questioning the reality around you.